Hi everyone. Oh wow.
This is
Oh, it's
their
working.
default theme.
Um, does anyone here not speak Dutch?
Yeah.
All right. Then I'll do this in English. Well, I'd like to welcome you all to our 15th iteration of Ode aan de Code, Ode to the Code. Yeah, welcome to our to the what is the final episode of our Ode aan de Code Racing Cup for this year. So if you haven't noticed, we have a play sheet over there. You have up until 10 o'clock this evening to set your record time and to win a chance to race us at Zandvoort. It's confusing all those Dutch and English words together. But anyway, without further ado, I would like to introduce our first speaker, Jeroen, who's going to talk to us about Golang. And from what I've noticed, I've looked it up on Wikipedia because I don't know anything about Golang. But I believe almost the entire internet is built on Golang. So you're going to talk us through how that's supposed to work, I guess.
Yeah. Let's first.
All right, thank you very much.
Sure. So let's get started. Yeah. Hi. I'm Jeroen. I'm a full stack developer. I'm currently working at the Next Gen project at my company, and I'm actually interested in everything distributed. So think about things like Kubernetes, Apache Kafka, and to create to avoid having a single point of failure. So I'm also an active open source contributor, and I'm here actually today to talk a little bit about Go and how Go is kind of helping us like solving and our problems, and then why we are using it. So all hail the monolith. I mean, this is a sentence or a thing that many of us have to deal with. A lot of us have like this big application, like a big bowl of spaghetti sometimes, that you kind of have to deal with. And so did we. The company is already existing for about 12 years. And over these 12 years, we've created a large technical debt. And it caused that a lot of parts inside of our code base were were really unknown and kind of caused a lot of issues. So what do we actually develop? We are in the construction industry, and we develop custom software for building firms. One of our main pieces of software is a piece of calculation software which allows companies to like estimate and create very accurate pricing offers and estimations for their customers, so that when you're building something that you're not going over budget, or that you actually know what you have to pay. And this is challenging because a lot of companies inside the building industry and the construction industry use legacy systems or very old systems, or like sometimes we don't even know the names for them. And that brings its own share of complications when making integrations and when trying to move forward for the industry as a whole. So yeah, I started last December. The project or the challenge got introduced to me. We started to look at this, and in the end, we decided that it's a great time to start again, to start with a clean slate, and not like that we're going to throw away all of the old code, but that we're going to start to take a fresh look at how to deal with this problem. I mean, the last meetup here at the Internet Jongens, we had a great talk about legacy code and about why you should not do this, but anyhow, we decided to do this. And that mainly had to do about the large amount of technical debt that we had. It was just too much. We couldn't handle anymore with it. So the approach that we took was a microservice approach, kind of pretty standard. We start to see this more and more often. Companies are all talking about it. But we wanted to go a little bit further, since we also had to deal a lot with sensitive data. We wanted to introduce event sourcing and event-driven architectures to allow us more flexibility and more to easier scale, and to be able to audit, for example, on the data that we're having. So we introduced things like Apache Kafka, Kubernetes, We started with Drone for our CI/CD, but also things like HashiCorp Vault to secure everything. So all pretty new. Our our first thought was to make everything in .NET. It was a pretty logical choice, especially since all of our previous application was written in C# and .NET Core, or .NET Core framework. But we wanted to look around since we had this possibility. So we looked at languages like Node.js, Python, all great options. But at some point, kind of the language Go got introduced to us. This is the Go mascot, the Gopher. It's a little bit obligatory, or you will see him pretty much in every talk. He's kind of cute and kind of dumb at the same time, and it kind of represents in that way the language, because Go is all about simplicity. And you probably have used Go. I mean, these like Docker and Kubernetes, just like two enormous projects, are fully written in Go. So just look up their GitHub, and you will see, and just look up in general, for example, on GitHub, on Go projects, and you will find a whole bunch of products that you're probably using on a day-to-day base that are written in Go. Also, a lot of companies are using Go. Just to name a few, American Express, etc., like Twitch, Dropbox. I do not mean that everything that they do is written in Go, but large parts of their corporations are written in Go, or they heavily rely on it for certain kind of parts. So what is it? What is Go? Now, I said already, it's a language got developed by Google and open sourced and introduced in 2008. Its designers, I just call them like Rob Pike and Ken Thompson, just to name a few quite big names. I mean, all from like the old days. Rob Pike was, for example, very much involved in the Unix story and the creating of it. So it's a static type language and a compiled language, like for example C. So you compile it back to machine code. But it's still at the same time really friendly, like what you would expect from a dynamic type language, like PHP or Python or JavaScript. And it's used across the industry in many different ways. I mean, you will see it in robots or robotic arms, to web applications, to whatever. So yeah, I said it already a little bit. Go is a modern general purpose language. It's a fancy way of saying that Go can be used for a lot of things, a lot of different things. And like there are like cool implementations like TinyGo and also WebAssembly implementations. I also mentioned this already a little bit. So it compiles some native machine code, and that Go does not just compile to just a general CPUs available, but also to some pretty abstract ones. I mean, if you've got a pretty old server laying somewhere, most likely Go will compile to its CPU. And this is great because this goes much further than just be able to have like to have machine code in your hands. It means that you can have a single file and I can hand it to you, and you will be able to run it. You don't need any runtime, any dependencies, anything. So imagine if you're a system administrator or DevOps, that means that you can just write your code, ship it to your servers, and run it. So you can have pretty lightweight things, pretty lightweight systems. And it results in quite small environments. Building Docker images is pretty fun. You get like 5 megabyte large Docker images out of it, and the Go binaries are even smaller. They're around 2 megabytes with everything inside of it. And Go is fast, and it's fast while still being memory safe. So you don't need to mention or like think about like memory allocations and releasing them and all of this shit. No, it's a garbage collected language. So you can just run it, and it can just like you just don't have to think about that. And It's important to note that Go is not just fast as a language, but also its compiler is incredibly fast. It's sometimes a joke made by Rob Pike, one of the designers, that Go got created while they were waiting for their C programs to compile. Because that was starting to become a huge issue at Google, where they had build times of 1.5 hours before they could ship code to production, or where they were making a small tweak, and then, yeah, we could grab a cup of coffee, or 2 or 3, and then it might be ready. Oh, that was wrong. And most importantly, at least for many companies, Go has an incredibly lightweight syntax. Most developers, probably when they start working, like when they get introduced to Go and when they start learning it, they learn the language within a couple of days, get good with it within a week, and of course, like the regular process to become a master in it, or like to become really comfortable after like a month or 2 of just intensive working with it. It's also very important that in Go there are no shortcuts. Your Go code should feel like mine. Like in languages, in certain languages, you can have a dozen ways to do a single thing. They try to avoid that in Go. Features are really well thought through before implemented, and a lot of people kind of are struggling with that at the beginning, but should understand that, for example, a map function in JavaScript or a find function that you could use in an array, it's just a loop in the background. So the thought with Go is to just write the loop, to make it clear that you're making a loop, and instead of making this abstraction. Besides this lightweight syntax, they have an amazing and extensive standard library with pretty much everything inside of it which you need. You have HTTP clients and servers, and you have system libraries to handle your disk write operations, read and write operations, and much more. So Go tries to have a single way of doing. So simplicity is key for code maintainability. When you want to look at, like, you don't want to have the feeling when you look back at code that someone else wrote, or that you wrote after, say, 3, 4, 5 years, that it's like, what is he doing here? Oh, he's using this abstract way of writing in C# from 2005. Now you want to feel like, oh, I understand this. Like, this is also how I would write my code. And Go has amazing tools to help with this. It has like an extensive suite of tools that help you format your code, to find bugs, to find to be able to lint, to enforce certain styles and techniques. So, about its simplicity, I made a small example. So, and to kind of show it, I got this small task. So we got a list with 3 numbers, and we want to iterate over the list and multiply all of like x by 2. For example, if we would do this in JavaScript, I could immediately already come up with 3 ways to do this. We could use the map function. Like I said before, you could just write a for loop, but you could also use the for each method, and probably as another smart developer could come up with like a dozen other ways. While all of these examples, all of these things are just like a simple for loop, and that's what I want to see. So this is how you would write it in Go. You would just initialize an array or slice called in Go with the 3 integers inside of it, and you would just iterate over it with the range syntax. And this can become an issue, like having multiple options when working with multiple developers. And like I said before, especially with developers that have to maintain and deal with kind of legacy code. Yeah, let's go further. So Rob Pike, of like Peter H. also said, write programs that do one thing well, for like one thing and do it well. Peter was a pretty big role player inside the development of Unix, and he's the one that is behind that pipe like functionality inside of, for example, Shell or Bash, so that you could pipe or stream content from one program to another. So he says, like, rather I see you write a whole bunch of different programs that all can connect really well than to write one that does everything. To go a little bit further on its simplicity, Go has also support for interfaces. Interfaces tend to be really small. If you take, for example, the read and write interface from the standard library, it is like it just contains one method, and that makes it kind of good, because a developer much rather implements one method than say 10, 20, 30, because then they probably would skip it and they would just create their own implementation. So a little bit further about tooling. I talked already a little bit about the amount of tools that are available. Here's just to name a few. So GoVet is for most, like for actually checking your code and catching already bugs, for example, unused variables or type declarations that are not possible. Go format makes sure that all your code, that all our code looks the same. Go code helps you with like getting documentation of a method, etc. And the list just keeps on going. So I got some demos prepared. I hope they're gonna work. I mean, let the demo gods be with me. And to give you a little bit more feeling about how this language works and what it's all about. So let's see. So yeah, let me check if I'm still going to type. Yeah. So I'm sharing my code. So I got my code here so that I can easier write, and then I'm sharing it with that screen. So this is like a small, like let's make this a bit bigger. A small crash course in how Go code. Oh, not my screen, please. Oh, whatever. I will manage. It's pretty lightweight. So every Go file should end with .go. The first line, or the first thing that should be defined in a Go file, is its package. I define here a main package, and the main package means that it can be executed from the command line, but you could also write just your custom package that you can later on import as a library. An important thing to note is now functions are defined with the func syntax. Like any language, it can accept multiple attributes, but it can return also multiple values, which can be quite useful later on. When a Go file is executed, the first method is being looked at is the main method. Variables are declared with the colon equal syntax and are statically typed. So this value is a string and cannot be changed after. So I got here a small example where I'm printing the line and I'm just writing it to the console. Lists can be buffered or unbuffered. So Go has an extensive like availability for memory usage. So I could say here that it only allocates 2 strings inside memory. And when you're writing code that needs to be very performant or where latency is a real concern, then this is quite a good thing. Go has also support for dictionaries or for structs. A structure is kind of like a JSON object or a class in C#. We talked already a little bit about the for loop, but the range property or syntax can be used for a lot of things. So you can range over dictionaries, you can range over loops, you can range over a whole ton of stuff. So that's just this. Let's just write something like a hello world application. So I will just create a main.go file. Is it syncing? Yeah, it is. So to start, again, like we just discussed, we write a package main file and our main method. And we could here say just font. That is kind of a standard a library from the standard library that allows you to write back to the console. And say like hello. Oh, if I can write, Gopher. Imports are automatically generated and detected. And is this opening as well? Let's see. I want to open a terminal. Yeah, perfect. Let's make it a bit bigger though. Yeah. And to execute this file, let's see. We first go to the folder, and you could just write simply go run main.go. And that's it. So while I executed this, it compiled the code back to binary and then executed the binary. I could also just create a binary just by simply writing go build main.go, which results in this main binary standing here. I don't know, can you guys all see this? I mean, I see you guys looking a bit around the table. It's a bit small. I can make it bigger though. Better? Better, okay, good. It also becomes bigger for me, but it's okay. So I got bloated text on my screen at the moment. So when I just execute go build, it compiles it for my CPU type and for my computer. I could also, with a bit more flags, can also compile for your CPU or for your computer. But I could just simply execute this file and it just runs. Like I said before, no runtime needed, no dependencies needed. So even if I import some third-party dependencies from GitHub or whatever, they're all included inside the binary. But this is pretty dumb. I mean, it's just hello world. We've all written it. So let's make a Slack CLI to show also a little bit about its networking capabilities. Yeah, oh wow. For that, I just forgot one thing, so let me do that pretty quickly. Is I need the Slack key. Oh, yes. So that should be included now. So what I want to do is, again, I want to create a main file or CLI, and what I want to start, like write a small Slack bot that writes just simple messages to my Slack channel. So to start again, we create a main file function, but we need now a bit more. We first of all need to communicate with the Slack API, and we second of all need actually structures now. We need to store data in a bit more interesting way. So let's create a struct. And a struct, like I said before, is like a C# class or like a Java class or even JavaScript. You can also append or attach methods to it, but structs are all about its data. So let's define a text field because we need it later on, and let's actually start like writing something. So I got in my environment variables the Slack webhook loaded under the name Slack webhook, and I could want to write a message from the message struct. So I'm gonna initialize it, and I say that the text inside of it needs to be again like hello Gopher. Go is immediately warning me about, like on my screen, unfortunately not here, about that these two variables are unused. My code at the moment will also not compile because it's part of the language. It really does not like unused variables, but it makes sure that way that all code that is written on the screen and that you see around, that it's actually used and that it does something. But the problem is if I just use the HTTP module to send a post to the webhook, I require JSON. So how do I get now a struct back to JSON? We've got therefore for that the JSON package again in the standard library, where we could just say JSON Marshall message. We get a byte buffer out of it. Optionally, and this is where the second variable is used a lot for, is an error message of an error value. For now, I'm just going to ignore it, and I want to use this byte buffer in the post that I'm sending. So bytes.new buffer, byte buffer, and we're good to go. Let's just log something to the console, and I saved, and then all the required imports like bytes, JSON, HTTP, and the operating system to load in the environment variable are loaded in. When I am compiling, when I'm transforming now this message struct back to JSON, the problem is that that text will be capitalized because the property field is text, and so it tries to make a one-to-one Marshall. We could give or define tags inside of Go, and tags inside a struct can be used for a whole a whole bunch of things. So, for example, if you use database packages, you can use tags to define the columns that you want to include or import. You could use tags to, like now, for example, to say like, hey, this JSON property should not be text, but message, or like text or whatever. And that way you could add a bunch of manipulation on top of it. And libraries and packages could just read out this tag or all the tags that are available. So this looks to me like, for me, it looks to be good to go. So let's go to the different directory and run the application. Well, let's first boot up Slack and see if it actually got sent. Just a second. Playground. So yeah, let's run it. Go run main.go. Success. And yeah, you hear the pop-up, but unfortunately it doesn't come there. But I received already this message in image channel. So this creates already a little bit more interesting application. This is already a bit more interesting to see, and all written within 25 lines of code, which to me is pretty amazing. This code, of course, I'm not dealing with errors. I'm not dealing with all that kind of stuff. But just the functionality of it is really straightforward. Let's go a bit further again. Let's get introduced into pointers. Oh, pointer. Main.go. So pointers are known from languages like more lower level languages, such as C. Oh, why is it having this now open? That is don't want. Follow me, yes, and also this. So a pointer in Go or in another language means that you could create a reference to a memory address, and that way you can avoid memory allocation. So you could write, create this enormous structure or this enormous piece of data that you're loading in, and instead of that in memory it's being copied or shared everywhere, you have actually the possibility inside Go to have fine-grained, like that you can tweak it, really, like, okay, here I want to copy everything, here I want to pass on the pointer, etc., etc. But you could also use it to be able to manipulate stuff. So I'm adding now just a method, like manipulate. I just want to rickroll or add a piece of content to the message, and instead of that I'm just returning the message, I just want to manipulate it directly. So to pass this on, to manipulate it, we just pass the message with the apprentice like, is that how it's called? Yeah, ampersand, like, in front of the message. And that way we're telling to the Go compiler and to the Go runtime that we're saying like, okay, hey, do not copy this memory address, but just pass it on, and this function is going to deal with it. And the compiler is also enforcing this. So if I just remove it, again, the program will not compile because it says like, hey, you're not passing on the memory address. And this means now that, oh, that's the wrong one. So if I run this one now, and I'm now, because you're not seeing the messages, if I'm just also now I'm logging it, message, run main.go, then you see also now that the message got added. And this can be really great for when you, like when you're thinking about memory optimization and about your memory footprint as a whole for your whole application. So this is another of like quite important like feature of Go. Another one that I want to introduce you to is called Go routines. And this is another reason why for a lot of companies they're using Go. Because in a lot of systems, in a lot of languages, we have to deal with concurrency. Whether it is that we want to read and consume thousands of requests a minute or a second, or if we want to read and write to an event bus extremely fast. Concurrent code is everywhere around us, and especially now that everyone is going online. So Go routines are pretty simply are pretty simple to define. So again, it's getting a bit repetitive, but let's write it once more. We're going to write a main file, and what we want to do is we want to go and sleep, and we want to count. Like we're going to count because it's hard to get to sleep. We want to count an animal, say sheeps, and to do this, we're going to create a for loop that has no exit condition, kind of like a while loop, but they thought like, hey, why not just call it for loop without an exit condition? We don't need another syntax for it. So we want to actually keep track of what we counted, so count, that's 0, and every time this for loop is called, count is getting increased. And then we're going to just say println, we're going to count, like log the animal plus the number that we are at. And before we're going further, or before we're logging it, we let it sleep for a second. So pretty realistic. So let's call sleep and call sheep. And I want to also sleep and also call chicken or count chicken. So when we're running this code, the problem is that that sheep, we will be counting sheep, but we will never reach this chicken calls of like this chicken method, because the for loop will never have an exit condition, but it just keeps on counting. So to be able to count this at the same time concurrently, the only thing we have to do is just write Go in front of it, and this runs then the code that you have, like this function inside a separate Go routine. And so that code can be executed side by side. So when we save this and run this again, now we will be counting chicken and sheep. Again, it's a bit small. The Go routine is not really comparable with threads. You can spawn thousands of Go routines at the same time. And this is being done, for example, at mail.ru. They have a great article about how they're dealing with Go routines and how they're dealing with like millions of users at the same time. And that's because a Go routine is just a small memory allocation that is being done. And that way it's really scalable. And a very kind of naive and obvious way to make this code look cleaner would be to just say like, hey, let's add this Go in front of it. But the only problem now is that the code will just exit. And that is because a Go a Go program will exit once its main Go routine, which is this one, is exited. So that's why we are spawning these two routines, but they're never executed because the main Go routine is being exited first. So Go routines are great, but the problem is now, okay, how do you allow them to communicate with one another? And a way of doing that is with a concept called channels. So I will just, do I remove it? No. Just for myself, I don't see otherwise anything on my screen. I'm gonna adjust it, and instead of that, I'm going to make the sleep method, and that we're calling it here. We're gonna write a health method that is going to return or to tell us whether our application status is healthy. So we're going to call it from here on, but we want to call it inside of a separate Go routine because this process is quite heavy. It requires some computation. It's doing various checks. So to be able to sync it up back to this main Go routine, we can create a channel. So chan, and I want to the channel is going. Channels are also typed like anything else. And we're just going to get a Boolean back, so a true or false, like, hey, I'm healthy, or hey, I'm not. And I want to just pass this channel to the health method, for the health method to just say, like, hey, yeah, everything is fine. And just to create a little bit of a delay, we're going to just say time.sleep and then time.second, just 1 second. Or we can say 2 seconds or whatever. So with this this symbol or this little piece of syntax, we're kind of saying like, okay, hey, push now this piece of data into this channel and make it kind of receivable and readable on the other side. And to read it, we can just say status, and we're going to just read it out. And in this case, the let's say result. I just want to log it back to the console. And one thing that I forgot, we need to actually like pass on the actual argument. So when we run this, pretty much what we expect happens. So the program waits for a second, and then it returns the true value that got returned. And this is very simple, but you can create like whole worker pools, notifications, relatively simple with this example. So to make something a little bit more complex, I'm just going to, why is this constantly changing? I want to see this. So I'm going to create a worker pool application. And this example kind of shows a bit more about what you could do with channels. So instead of writing, I will just show it a little bit more. So what we do is we create like our main method. We're going to create 2 channels. We're going to create jobs, and we're going to create results, because we want to have both of them separated from one another. In this case, I'm just going to create a small for loop to create 3 workers. I could have also just called the worker method 3 times, but this works as well and is scalable. I'm going to run them all in separate Go routines, so they're all running independent from one another. And then I'm going to add 5 jobs. 5 jobs with an increasing integer. Let's see. Then afterwards, I'm just going to say, I'm going to close my jobs, like, hey, this channel, I'm not going to send anything else anymore. And I will be afterwards reading out the results that are being returned by the workers. The workers are received all an ID. They receive this job channel and the results channel. And you can just, again, use this range property, and in this case, to range over all messages that are being sent over the jobs channel. And I'm just going to print some stuff. So I'm going to print who I am, what I'm going to do, and I'm going to return results. So the integer, or like the number that is being sent to me, times 2. So where's my mouse? There it is. bit confusing. So we could just run this. Oh. There we go, terminal. So when we are running this, oh, I didn't save the file. So we see the workers being spawned. Let's try to make this a bit larger. I don't know why it's not working, so that's a bit sad. But the workers are being started, they're all starting to process, and we can just increase this indefinitely. So just imagine you're having, for example, this application, we create this simple worker pool, and we're going to send out emails. So instead of doing one email after another, we can just spawn as many workers as we think our CPU can handle and our bandwidth, and then we can just start like working much more efficient. So let's go back here. All of these examples, I pushed them to GitHub. You will find them here, and after this talk, I will push the slides to the meetup.com so that you don't have to remember this. So this demo is okay, and but again, like, where should you use Go for? Like, what are the actual pros and cons? So a pro would be to have a great developer experience. If you're planning to build something large, or you want to just have excited developers, then it's a great language to choose from. When latency is actually a real concern, so you're really able to write like fast code relatively easily. The code that I shown here will be production ready and will be able to handle tons of requests or tons of user load. And when you want to have a good ecosystem, some languages, for example, take JavaScript with its ever-ending frameworks that are constantly rotating. Go's ecosystem is relatively stable, and the Go community around it is really experienced and is focused on this. But of course there are cons. I mean, there are also cases when you should not use it. Generics, that's kind of a big issue. It's not there. And by purpose. When Go got released, generics was seen as something that would cause a lot of like messy code and a lot of like stuff that could be hard to implement. But it could be a real reason for companies to not use Go. Though generics is being implemented in Go 2.0, we still don't know how, but it's on its way. Error handling isn't perfect, and I don't mean that you cannot handle errors. Error handling in Go is great, but it's implemented in such a way that each and every error has to be implemented, has to be handled, and the if error is not nil statement can overflow your code quite easily and create a lot of boilerplate code. But again, this issue hopefully will be solved and be tackled in Go 2.0. And it's not a perfect language for prototyping. With these those two reasons as mentioned above, that's a big reason for it. But if you just want to write something really dirty, really quickly, Go will not be a good language because of, for example, that errors are thrown silently. You will not get stack traces back or anything remotely like that. So if you want to learn more about Go, here are some useful resources. They just released and announced the go.dev domain with tons of great links, videos, and books. Golang.org, the official Golang website, is still a great place to go. They have a great tour that you can follow in just like 15 minutes, and you get a pretty good understanding of the language, and you can play around with it in its playground mode. If you're that guy that likes books, here are some that I would recommend. The first one is one that caught my interest, or that I read and that got me excited about Go. But the other two are also highly recommended. If you like videos, courses, Code Academy, etc., have great videos, all for free or for like very small amounts of money. And I just want to thank you all. Are there any further any questions? No? Then I all want to thank you very much. Yes.
All right, Jeroen, thank you very much. Of course, thank you for this wonderful talk, but we do not want to let you go without a gift.
Thanks.
There you go.
Yeah.
Thanks.
Okay.
But wait, there's more.
Oh. Thanks. Wow.
Enjoy.
I will.
In the meantime, let's take a 10 to 15 minute break. If you find the time, take a seat and drive a lap at Zandvoort. You're all still in the race, so yeah, let's have a break, grab a beer, something to drink, and we'll see you in 15 minutes.
Oh, licht.
Yes. Yeah, everyone found their seats again. All right. Thank you for joining us again. I had to promise not to reveal anything about this talk because this will be, from what I understood, a premiere. Yeah, flown over all the way from SymphonyCon today. Let me give the microphone to Bart to talk about maintainable database integration tests.
Okay,
Give it a go.
Thank you. Thank you for having me in the first place. I see that most people are still here, so I'm honored to have you as an audience. It's actually a pretty large group for a meetup, so I'm very happy to see you all here. This is about maintainable database integration tests, and maintainable is an issue with database tests, and they are integration tests because they work with a real database. So it's not about mocking data classes to fake that you have a database. You're using an actual database, and this can lead to issues because if the structure changes, you might need to update your tests. And I have thought of a system to avoid that, and it's more of a way of thinking then it's about using certain libraries. So if you see that I use certain libraries or framework components, that is actually purely accidental because I'm familiar with them or because I just like them or I wanted to try them. So you can use the line of thought, I think, in any programming language. So that's important to keep in mind because at the end it will be a demo. The demo is not 100% complete, but it runs and you can get the idea and we can break it and you can ask me to break it to see what happens. So a database integration test asserts that your application interacts with your databases as intended. So there are a few key things here. I already mentioned integration, so we're talking real database. It says assertion, so you want to make sure that things happen the way you intend them to be. And that's really important because you can make a lot of assertions, but if you want to make sure your application works well, then you have to think about intention. You always have to think about intention also already at the moment that you start coding, because you get better code from it, and you get even better code when you write tests along with your code. But I hope you all know that already. So here's the big why. why database integration tests? Because one of my colleagues said to me when I introduced the concept at my previous assignment, he said, I don't see the added value. We have all these tests that mock the database, we have even regular tests that touch the actual database, but those were not fast. They had to load a huge fixture with data about everything the company had in loads. So the fixture was slow to load, and then you could run tests against that. But once you had random, the changed data would remain, so you couldn't run them at the same time. You couldn't run them over and over again because the data would be changed. So it's not fast in an integration system, for example. When you want to need to wait for your build, it has to be fast. But the main reason why is still bug finding. Every single time that I wrote a database integration test for the existing code, I found, well, no, not for, when I wrote it for new code, I found always 1 or 2 bugs in the code I was writing at that moment. When I wrote it for existing code, I found edge cases. Like, not necessarily, really edge cases, not really max-min values, but also null values, undefined situations that were not handled by the code. So if you would encounter those in the real-life application, there would be a problem. Research has demonstrated that if 2 undefined cases, so let's say a case where the code doesn't decide what to do, whether to throw an exception or return false or whatever, it just leaves it hanging in the middle. If 2 of those cases come together, you get a serious bug that costs money. So unhandled cases are really important to not have. And also design flaws. If you are inventing something, if you're designing a new system, your tests help in actually understanding if you did it all right or not. Well, a database test should be reliable. Well, that's very obvious, of course. It should be easy to write, because coding should be fun. That's at least what I think. And when it's easy to write, it's also fun to write, usually. It should be easy to read. It should be maintainable, because you don't want to have to go back to it. It's best when it maintains itself, and then you don't have to maintain it. It should be fast at test time, and that's something that we were concerned about in the company where I created the idea for, because they had these huge bloated models with lots of relations and even recursive relations. And if you had to create those from code in your tests, they would be very slow, because in the background they would be creating many, like tens or hundreds of PHP objects in memory to achieve a certain amount of data that you could run tests on. So I thought about that and I came up with a solution. More about it later. They should also be easy to debug. I like to step debug with xdebug. I use PHP, so use xdebug, and you want to be able to step through your code. If you use PHP to load a big fixture in the background, like the test we had up until that point did, your debugger might hook into that process and might never reach the code that you actually want to test. So may just hang in the background and nothing appears in your debugger and you can't see what you're doing. So that was also one of the demands we had, that it would be easy to debug. And it should be easy to delete. Because if you do not need the logic anymore and you throw away the models or the class you're testing, you'll also want to throw away the test, and it shouldn't be all over the place. It shouldn't have resource data in a folder somewhere that's called resources or data. and the test case in a database integration test folder and configuration somewhere in your config folder, because then you need to search for this. And if you are deleting data resources, how can you be sure that they are not used by another test as well, that they are not reused? You have to search for that before you can delete it. So what you will probably do is you will just leave it in place and not clean up, leaving a big mess behind you. So easy to delete is, at least to me, is very important, because I don't like messy code. Well, reliable. It should not mess with your actual database. If you have a database you use in development, it's also, for you, it's a production database. You might have data in it that you are using to test the UI visually. You don't want your tests to touch your actual development database. You want it to use an empty database and do everything in there. A dedicated database that's only for your tests. You want up-to-date database structure. Up-to-date lookup tables is about when you have, for example, certain values stored in XML, and you never, this is fixed data, it's a list, for example. And it's loaded during the setup of your project into the database, and then it's used from the database. But there are no models that create those records. So you can't use models in your tests to create those records. And you're also not using the processes that normally load those lookup lists. So you have to find a way to have them in your database, and they're not changed, the fixed lists. So once you have them, so they can be in the dump or they can be next to the dump, but you have to load them before you start running tests, because otherwise you are missing all the lookup values. Well, you need to have up-to-date table structure, because if it's outdated, then your models will break. And I already mentioned that you want to create your datasets with your application code, so that the data is the same as when your application had created it. If something's unclear about what I say, feel free to interrupt me, because easy to write. So my solution to make it faster test time is to write a script or a Symfony command or whatever you like to create a dataset at development time. So you write code to generate your data. You actually, most people do that when they write database integration tests. They add some things to the database using code. But usually they do it in the test itself. And the good thing about it is that everything is kept close together. So when something goes wrong in your test, you can go up in your test and see, where did they add this? Is it really there? Did they make a mistake? But it also clutters your test, and it's slow. So do it separately in a command. Like I said, no mocking of the data layer. It's an actual database. You can have mocks, like for example, an external system like a web service. You would still mock, because you test the integration with your database. You're not testing the integration with external services. And only test input and output. Don't go into the black box of your code and assert that a certain function is called 2 times. Who cares? It's a black box. Given a certain input, certain output should be given, should be generated, right? Easy to read. Well, bloated mocking code is avoided. Bulk data creation lives outside your test, so you don't even see it when you write your test. And only do assertions and statements that actually test business logic. The rest shouldn't be even in your code. But well, how do you make it maintainable? Well, your point of departure is the database you use for development. So you run all your migrations, all your database migrations, so that your database is up to date with the state it should be in for the branch you're working on. Then you dump the database structure, so that you have only the structure. This loads really, really fast. There's nothing slow about it. You dump all your lookup tables. And then you run the commands that you wrote for your tests that create all the data sets. And because you create those with the models in your application, you now have up-to-date structure in your data sets. Because you already ran the migrations, your dump is up to date, and the commands, that is scripted code that generates data based on models. But those models live in your branch, which is up to date. So they create up-to-date data sets. If you have added a field, like is favorite, for example, which could be 0 or 1, that will be in your dataset after you have rerun the command that creates the code. And then automate all of the above. Because you, so that each time that something's changed in your database, you can just say, okay, create my datasets again. And it will do it for you. All of this can be automated. There's nothing, no rocket science about it. And faster test time, well, data loaded in bulk is fast. And you create minimal data during your tests. If you're testing if something can be created, and if it is created the way you intend it to be created, then you have to create something, maybe 1 or 2 records. But the bulk that is needed to facilitate that is all done in the command that you have scripted separately. And there are very few statements in your test, so there's very little code to execute, which also makes it fast. Well, easy to debug. If you do it this way, there is no secondary process. You just run your test, so your debugger kicks in right away if you have set the breakpoint. Easy to delete. Well, my solution to that is to not have just a class for your test, but to have a folder with the same name. And in that folder lives your test class, the data generation command, and a README that tells you why it's there and how you should use it and how you can maintain it. And I have here a second bullet point that said, except maybe configuration. If you use Symfony commands, they tend to be configured somewhere else in your config folder, so then you also have a configuration section for your test. Actually, while writing the demo, it's not completely finished yet, but I found that you don't even need that. If you do a few different things, like have a facade for configuration or a facade for services that you want to use during testing, you could even have that in your folder ready for your test. So then you could delete everything in one step. So then the directory structure looks like this. You have test, integration, DB for database. And then there's my my classes from the demo. I have a company, I don't really have it, but for this demo I have a fruit company. I sell fruit and I want people to be able to filter on what kind of fruit it is. And the filter is the use case for a database integration test, because you can defend using mocks by saying, okay, yeah, we know what it's going to return, so we can mock it. But if you make a typo in a filter, in a function that filters, your mock will never notice. It's just going to say, when I call filter function, I get this data back. And if you make a typo somewhere, you have, for example, hard-coded the name of the genus of a fruit. You have hard-coded it there because you were rapidly developing and you just wanted to check if it worked. It will always return the same list. And when you ask for a different genus of fruit, it will still return the same list. And the database integration test will actually figure that out, unless you do the same hard-coded filter in there. But you could use a data provider or something to cover for that. What's in here? Under fruit company, there is DB test, which is just a parent class that does like get a connection. I think it only gets a connection. And it allows you to get a DB adapter, but that's an implementation detail. Then the repository that is tested here is responsible for getting you a list of fruits. or even save a fruit, but I haven't tested that yet. And there is a prepare test DB PHP script that should do things like making sure your structure is loaded, making sure your lookup lists are loaded into the database. It doesn't need to be empty because the structure will also drop all the tables. So if it's not empty, it will make it empty. In my demo, it's currently still empty, but it's really easy to write. And the structure.sql is just your database structure. It's just empty. And if there are lookup lists, I don't have them in this demo, then there should also be a SQL for that. I'm Bart McLeod. I'm a PHP developer. I'm Cent certified. I'm also a painter and sculptor. So I do a lot of that as well. My Twitter handle is there, and my blog, which is very much outdated. Any questions so far before we dive into some code? Everything clear so far? Do all of you already test your database with integration tests? Who doesn't? One? It's one person who's honest now. Who doesn't? Who doesn't do database integration tests? Everyone? You're just too ashamed to admit it, right? So, oh yeah, some shameless plug. I wrote a book. It's actually a small guide. Any of you does PHP? Wow. Any of you ever encountered a Zen Framework 1 application? That's still... So this is a... Oh, whoops. Holding it upside down. This is a guide on how to migrate Zen Framework 1 application to Zen Framework 2. It's old. They took 2.5 years to publish it after I wrote it. But it's still useful. You can, if you like it, you can have it. It's still useful for later versions of Zen Framework, which we don't know how to call because it's now separate components. So you can't call it Zen Framework 3 because the components have their own versioning. So let's just call it Zen Framework. Well, demo time. Right. Let's see if everything still works. If Docker is up, yeah. So, is that big enough for you? I don't think so. How do we do it? Okay. This is a fixture command. Is this big enough? Yes. Cool. Okay. Let's make it a bit more focused. I think you can also make it a full screen. Right, so what am I testing? Well, let's first look at the database. This is the development database. It's called Fruit Company. And it has, oh, sorry, that's my connection. This is the database, it's called Fruit Company. This is also small, but I don't think you can enlarge this bit. So you have to take my word for it. It contains cultivar, which is the actual fruit that you buy in the shop. When it's, I have names here somewhere. That's a specific race of apple or tomato that you might buy. And species would be like apple or potato or tomato. And genus is even higher up in the biological tree, but I didn't go all the way up. There are, I think, 7 levels above that that are more of biological interest than of anything else. It's a very simple model. The genus, the top level, in my case, just has a name and an ID. Species, same thing, just a name and an ID. But it gives you something to filter on, which we need for the demo. And cultivar also has a name and ID, also species ID. Oh yeah, and species has a genus ID because they descend. And it also has a Boolean value that tells you if it's edible or not. And they're all edible by default. In my case. What? Yes. Now, what shall I show you first? There is a cultivar repository that actually works, and it has get by genus, and so you pass it the ID of a genus, and it will get all the fruits that have this genus. And you also have get by species, which does almost the same thing but lower in the tree. So if you say get me by genus all the nightshades, you get the potatoes and the tomatoes. If you say get malus, you only get apple. If you say get by species, you only and you pass the apple species, you only get different kinds of apples. That's the idea. What does the test do? Because that's I think the interesting part. Repository tests. It says here test get by genus, and it needs a repository. So it just initializes new repository with a database adapter. And then, yeah, here's a little to do. I'll come back to that later. It says I want all of the nightshades. I happen to know the nightshades are at ID 1. And this get by genus is a generator. That means that the results are not buffered in memory. So you get one result as soon as it comes back from the database, as long as you haven't buffered your database. So you need a few settings there to actually benefit from that. But yeah, so you actually get them one by one, and that makes it so that you can't count them. You can't say, oh, count this result. That's impossible because you don't know what's coming. It's actually pipeline, and they just drip out at the end, and you know how many there are, so if you want to know, you have to count them yourself. But that's just detail. So I'm saying for each nightshade as cultivar, count them, and assert the same. So I want to know if nightshades is the name of the genus. So I say cultivar get species, because that's just above cultivar is the species, then above that is the genus, and that has a name. So I'm just asserting that when I want nightshades, I do actually get nightshades. So this is testing business logic with very simple code, and also very simple assertions. And there's no bloat around it, mock this, mock that, make sure that your database adapter is called, make sure that the connection is made. You don't care about that. You do care that it works, but once it works, you don't care about it. And then I want to assert that I have actually 7 nightshades in my project. You can get this ID dynamically from your dataset. Suppose you dump your database structure somewhere in the middle of a big project. Your auto-increment ID might be at 8,000 because you entered 8,000 different cultivars of potatoes, which is possible because there are actually 8,000 variations of potatoes. And then you add a few apples, and the auto-increment ID goes up by another, I don't know, 500. And suddenly, and you add a few genuses because you're adding more fruit, and suddenly your auto-increment is at, say, 87. So this would break, right? Because you have dumped the structure, and the auto-increment, also detail, is in the structure. It says auto-increment next value 87, something like that. And you can reset all those, but that's extra work. What you do know is that this particular genus is the first that you add in your dataset. And there's actually a convenience method here in the parent class. We'll enlarge that. That says get ID from dataset. And it just, and there's a little conversion for the position, because you want the first one, right? The first is nightshade, so I say give me number 1. And it's actually it's an XML, and its index is 0 based if you load them into memory. So you have to decrement that, which you can do in PHP by adding minuses in front of the $. And then you can say, okay, get dataset, get table, get value from this position in the dataset from this field, which is very convenient. And if you have such a method, you can use it anywhere to just get that ID. So if I actually do that, well, let's not break it right now. If I go back to the cultivar test, test by species works mostly the same way. So it's really, really simple. Do you think it's time to break this code somewhere? Would it be fun to see it fail? Yes, I thought you might like that. Cultivar repository. Oh yeah, this is nice. There is a query somewhere here. And it has joins because I want to build a complete cultivar object, including species, including genus. So I've joined them so that I can get them all in one go, and I have one query to get everything. And since all of them have a name, the results actually overwrite each other. So if you have something with a name in the second join table, it overwrites the name from the first, and the last one will overwrite both of them. So if I say here, I don't alias this, but I do it like I had it when I was building this demo. And just to make sure I do them both. Now it should break because, maybe not. Maybe not. Yeah, one of them should break. Where are we here? Let's hope it breaks. Yes. Well, there's actually more breaking than expected, but I probably put in some safeguards somewhere so that I now have a null value. Because what I was hoping to see was that the name would be overwritten and that it would say something like potato doesn't match nightshades or something. But we have a different problem. But you see how it safeguards you against mistakes, right? Do you want to break more, or do you want me to fix this? Genus repository. Do you have questions so far? Oh God, where am I? This is so big. Oh yeah, query I was doing. Oh, this is the wrong repository. Oh, okay. It's this one. Cultivar repository. Right. Oh, and it should be fixed again. Yeah, there's something else I would like to show, but that's not completely finished. I have here repository fixture command. What it does, it has a fixtures class as a property. You can nicely inject it with dependency injection if you have that in place, or you can do it any other way. This is actually a Symfony command because it has certain benefits when you do it that way. If it doesn't have this fixtures class, it will throw an exception. And then this fixture class knows how to make complex objects. These objects are very, very simple, but when I invented this, we had to deal with very complex objects, and you didn't want to create those in your tests. You wanted to have a really, really easy way to create those. So what I did, I created this big fixtures class that I called stubs. Don't know why. And it had all the repositories. So that was long configuration because each time you added a test, you wanted a few new entities to be able to be created by it, but it doesn't matter. You know, it's testing code. You wouldn't create such a big bloated class for production code. You would never do that, but you can do it for your tests, because all it does is create entities that have complex relations with each other, and it takes care of that. You could also split it up in multiple classes, but it only makes it harder. You would still have to group them in a big class that you, because that big class, the fixtures, you can just inject them into any testing code generation command, and it will do for you what you need from it. And if it's missing something, you just add a method, and maybe you add another repository to it. So it's a very powerful class, and it can do simple things like create a genus with this name, and create another one with that name, and create a few species, and then create a list of names of potatoes, a list of names of tomatoes, a list of names of apples, and just for each potato name, create a cultivar, do the same for tomatoes, do the same for apples, and you're done. And then you have this optional argument that you can give to your command, because you could also create datasets one by one at development time. That is the dump argument, and it should actually be like this. While I'm at it. Oh no, that's not true. That's somewhere else. When this option is true, it will just dump your dataset. This is not run at test time, so it's not a second process, because this is the way in PHP, a way in PHP. PHP has many ways to do the same things, unlike Go. This way you invoke a command in your shell. So this will also fail if you do not have MySQL dump installed, for example. And this dumps the dataset. And this code is also wrong, obviously. It has all the hard-coded settings, but I have already created a config facade so that you can get actual configured values in here, and the dataset should be dumped to the current directory, so it should be prefixed. This is a work in progress. I had all this done for this customer, it all worked, but it's so confidential, and it's all way too complicated for a demo, so I had to recreate everything. And it was a lot more fun than I expected, so it took me a lot longer than I expected, because it was so much fun to do. Then you can have this Fixtures PHP class, which is super, super ugly, because it does all kinds of things that would normally be done by a dependency injection container or something else that's nice and that you already have in place in your application. But it actually gave me the idea that all of the test code can actually be contained in one directory. If you have a few facades that give you objects to work with, like the database adapter and the configuration, you can just call this from your fixture command, and there's really nothing that you need outside of your test that is specific for that test. So if you want to throw away your test, you can throw away your test directory, and it's all gone. And I think that's good. So this creates a DSN for the PDO. That's the way, one of the many ways in PHP to talk to your database. It makes sure it throws exceptions when something goes wrong. Creates a driver, this is send framework specific. Creates an adapter, also send framework specific. And then it creates the repositories. It creates a new fixtures class, and it gives it all the repositories, and that's why the fixtures class can create a genus, a cultivar, etc. And if these were very complex models, this would give you a lot of added value. It defines a list of commands. This is something you can maintain manually, or you can use the Symfony configuration. And you can't call execute on them. You have to call run. You also have to add an output interface to it. No, that's not what I was looking for. So, and there was something else missing. Oh yeah, that's here. That should be true. So you just fake input from the command line, because you're automating dumping datasets. So you want a list of all your dataset dumping commands in there. Oh, that's actually one extra place where you need to delete something that belongs to your test. Unless maybe you would find a way to have your test automatically insert itself in your configuration at runtime. I don't know. It's probably a pattern that will fix it for you. But this is then the one place where you need to add it and also remove it when you delete it. This is just fake user input presented as an array, which is very convenient. And then you can say for each command, they all implement the same interface. So you can say new command class name, command name. You could even inject the fixtures here, which would be slightly better, but I only learned today that you can do it. You set this fixtures class so that the command can use it, and then you run it, and it dumps your dataset. And when you have configured the actual correct absolute path to your dataset, it ends up in the same directory as your test. So it's also contained within the test directory. And I'm afraid I can't enlarge that, but maybe in presentation mode. View, presentation mode. I hate presentation mode, but oh, they got rid of it, I think. Where is it? Appearance? Wait, no, appearance. Oh, here, file, view, appearance. Enter presentation mode. I hope I can get back out of that. Oh, it doesn't show the project. Too bad. God. Yeah, I can't get out of it.
You can do a Command Shift A and then type presentation mode and you can toggle it off again. Should be the default binding at least.
I don't have default bindings.
Or double shift, try that.
Whatever. I could also just quit it and start it again. I hope it won't get back to presentation mode. PHP Sharp. Right. Ooh, 2.5. Ignore. Yep, we're out of it. Good. Maybe if you show the project tree, it will work, but let's not risk that again. I also had the directory structure in my slide, but here is the dataset. It's in the same, and I can enlarge it here. And this is just standard MySQL dump with the XML flag on. And oh yeah, there's one thing I need to show you in the test. Adds a bit PHP detail, but still. It has this single method here. Enlarge again. Create MySQL XML dataset. So that uses the output format from MySQL to load this dataset. Then the big drawback for those actually interested in PHP, this extends a test case from dbunit, and dbunit is discontinued. I've been tempted to continue it myself, but I don't have enough time, so you can still install it. It's still on GitHub. You can fork it yourself if you really want to make sure that it's kept, or if you want to maintain it. Yeah, but what you use from it is not very much, because the assertions that I used in my test are just regular PHP unit assertions, and PHP unit is continued. It's just the DB unit flavor of it that is discontinued. And I have this get connection method that is automatically used underwater to get a connection to the database. And you have this create dataset method that inserts all the values in your database. And there are also methods that I haven't used here yet that can clean up after you've run the tests. But they probably ran by default, because I saw no problems when they ran it multiple times. And it should have given problems if that were the case. So it cleans up after itself. So you can run over and over again, and all the tests are isolated. So values from a previous test are not messing with your current test. Okay. Oh, wait. There. Are there any questions now? Have I puzzled you? No. Did someone learn something? Because this is...
So, like you've shown a lot about integration tests. What is your you've shown cases in where integration tests are better than just to mock everything.
Yes.
But would there also be cases where you would really say like, hey, let's go and mock stuff and not?
Yes, definitely. I attended a talk by the inventor of Codeception, which is a famous PHP testing library, and he said, well, you only mock systems that are beyond your control, outside of your control. This could be an external web service from a third party that your production code connects to, and that you just want to mock. But systems that are within your control, that you could spin up if you would make the effort, you can just write integration tests for. And those are better, because if you have made a mistake somewhere down the line, it will surface. And if you have mocked it, it will stay all right forever. Suppose you have your own API, gives you a certain JSON response, you can store the JSON response in a file, you can load it into a mocked response, and you can do assertions on it, but they will always be good. All you have tested is you can translate the response into objects, for example, if that's what you're doing. But if something's wrong in generating the response, you won't see it. So an integration test in that case is more likely to show you where there are problems in this other system. That's also under your control. On the other hand, you could argue that maybe you want to outsource that system maybe someday to a third party, and then your tests suddenly depend on it, while you can no longer spin it up, at least not the latest version. So then you could still argue that the mock in that case is better. So again, it depends, of course. And it would be good if, for example, in this API example, the thing you want to test is that you can build objects out of the response. If that is what you want to test, yeah, of course you could mock it. But best is, I think, it's a good idea to mock only systems that are not under your control, or that are way, way, way too difficult to spin up at test time. Because you want your tests are best used when they are also run by your integration server, and that must be done really quickly, because otherwise you're waiting for the build forever. It must be possible to run them in parallel, ideally. But if you use things like caching and so, that can be difficult. If your integration test is putting things in the cache, and your unit tests are running at the same time, and they're also putting things in the cache, those can collide. But ideally, that would not happen, because the unit test should not do that, and an integration test should be able to be self-contained and clean up after itself. Another question? No? Any other? Is there someone who thinks it's absolute bullshit, that it has no added value? Really, no? No one? Okay. So, well, in that case, I would like to thank you. Is there someone I can make happy with this guide? If you ever encounter one of those awful monoliths of Zen Framework 1 applications? No? Yes? Someone. Oh, okay. You make me happy, sir. There you go. Okay, so thank you all for your attention.
All right, Bart, thank you very much.
Welcome.
And of course, also a present for you.
Thank you. That's great.
And well, I'd like to thank you all for joining us today. please have another go at our play seat at about 10 o'clock. That is about 55 minutes from now. We will reveal who has won our trip to a trip to Zandvoort. So, yeah, thank you very much for joining us. Let's have another beer or non-alcoholic if you still need to drive, and then have fun. Ja, maar niemand geeft dat aan en ik kan er niet heen en weer lopen de hele tijd.